So here in lesson 36, we are solving both exponential and log equations. And again, I'll take a little break in between just so you have a chance to ask some questions or do some practice. I've mentioned this many times, but exponential and log functions are in fact inverses, aka opposites. That's why they both appear in chapter 3. There are a lot of applications of the fact that they are inverses, but we're going to start with these properties below. So take a look at the two left-hand side boxes here. If you have a problem where it's log base b of the same b being raised to something, as long as there is nothing in between the log of base b and the exponent of the same base, they do in fact cancel to leave you with whatever the value of n is. Similar scenario for the ln. Remember that the base of the ln is of course e. So if you have ln base e of e to the something, as long as there is nothing in between, you can safely conclude that that is equal to n. So this is a simplification strategy. Again, the reason why it works is because of inverses. It also works if you are talking about starting with an exponential. So underneath, if you have some exponential raised to a log of the same base, as long as there is nothing in between, you can safely conclude that that is equal to a. And it also works the same way for e. This is e raised to the ln base e. As long as you don't have anything in between the e and the ln, you can go ahead and simplify that to be a. So consider, if you would, the ln of e to the 3x. That's kind of the dream, as easy as it gets. Because this is ln base e of e to the something, you can just go ahead and cancel those out to give you an answer of 3x. Again, there isn't really any work to do. You are just using the property. How about the one directly to the right of it? The ln of the cube root of e squared. You might not think that that cube root is in the way, but it actually kind of is. So before the property will work, you want to go ahead and rewrite the problem as the ln of e to the 2/3. And again, as a reminder, the index goes to the denominator. Whatever this exponent is stays in the numerator. And then now, because you have ln base e of e to the something, the property holds, and you can go ahead and just simplify this to be 2/3. The hardest that is ever going to get is something like 10 to the 2 log x. Again, the 10 and the log can't have anything between them in order for it to work. The way that you can simplify this is because there's a log right here. Because of the fact that there's a log right here, you can actually use the power property, which says take this 2 and move it up to the top. That's now going to give you 10 to the log of x squared. By moving that 2 up to the exponent, you now have 10 raised to the log base 10. And as long as there is nothing in between that base 10 and that log 10, you can go ahead and simplify this to simply be x squared. Any questions on those three? All three in that row use the property to the left. And now underneath, all three in that row are going to use this property to the left. So e to the ln of x plus 2. Mind the fact that there are parentheses here. That's valid, okay? The fact that there are parentheses means that that x and that 2 have to stay together. Because of that parentheses, this is e to the ln base e. The property holds, those cancel, and you're simply left with just x plus 2. Compare that to the one next door. It is still the ln of x plus 2, but it's not the ln of the quantity x plus 2. So the fact that there are no parentheses in the second version actually means that this problem is quite different. While you could simplify just this part, what would you do with this dangling 2? Well, let me show you. Because of the fact that there is no parentheses, you need to write it as such. E to the ln of x times e squared. First of all, why are you allowed to do that? Well, if you now were to try to go in reverse, e to the something times e to the something, you would add those somethings, which would give you back to the original. So you're just using the property in reverse. Again, you can't do this like the one on the left because there are no parentheses. If you try to use the property, the 2 is going to somehow be left by itself, and you don't want that. So by separating it into e to the ln of x times e to the squared, you can now use the property for the first quantity. So e to the ln base e, that simplifies to just be x. E squared, unfortunately, cannot simplify, which means you're just going to leave them as a multiplied answer. Max? Uh-huh. No, when you have the same base and you're multiplying them, you just add the exponents. You don't do anything to the base itself. I mean, if I had 2 to the 5th times 2 to the 6th, that would be 2 to the 11th. You don't do anything to the 2's. Anybody else? What if what was in parentheses? So, like this? Yeah. Wouldn't, same answer. If it was like this? Like this? Still be the same answer, yeah. I don't think you'd ever see that. If you're going to see parentheses, you'll either see them around both or around neither. But yeah, even if there's one versus the other, it still applies. Okay, and then one more. So log of 10 to the 3x plus the ln of e to the third. In this case, it's using the property twice. So here, log base 10 of 10. Don't forget that this is base 10. So that purple quantity, the whole thing, simplifies to be what? 3x, okay, good. Plus, here's the property again. This is the ln, which remember is base e of e to the something. So that entire yellow quantity simplifies to be what? 3. That's a perfectly fine answer. Some of you might be tempted to factor out a 3, which is fine as well, but I would accept either one. So it is important that you know the properties. Again, over on the left here, technically the yellows are both the same property, one with an LOG and one with an LN. And then the purples are the same property, one with an LOG and one with an LN. But again, it is important that you know them for simplification purposes. Why do they work? Because exponentials and logs are inverses. We will talk so much more about the fact that they are inverses. But for now, this is what we know to be true. And again, just a quick note about these problems. The ones that have x's in them, you are not trying to solve for x. So don't set it equal to anything. Simply leave it as a simplification. So any questions on that set before we move on to the next? The next two sets of boxes are all going to be about solving exponential equations. There are two ways to solve exponential equations, one with like bases and one using logarithms. So I'm going to show you both. A note about exponential equations: the domain of exponential equations is all real numbers. What that means is you do not need to check your answers. While it is possible that exponential equations can have no solutions, they will happen organically. You don't need to actually check your answer. If you're able to find an answer, you can assume that it works. If for some reason there is no solution, it will happen organically along the way. That is way different than logs, where you do have to check your work. So let's start with number 1. You are trying to solve for x. In order to solve for x, we have some steps along the way to do, and those are algebraic steps. So suggestions for what the first thing that I should do is, just algebraically, take the 3 and subtract it. So you're going to get 2 to the 3 minus 2x equals 11 minus 3 is 8. Hopefully, once you get down to here, you see a 2 and you see an 8, and you think to yourself, I can use like basis, which you can and should. So 2 to the 3 minus 2x equals, how should I rewrite 8? 2 to the third. Again, the point of like basis, if you now have 2 to the something equals 2 to the something, you can drop the basis and set the exponents equal. If you subtract 3 from both sides, you get negative 2x equals 0. If you divide by -2, you get an answer of x equals 0. Again, there is no need to check that solution. As long as you get one, you can safely assume that it works. Let's say you did want to check to see if it works. Everywhere there's an x, you would put a 0. That would give you 3 plus 2 to the third, which would in fact give you 11. So as you study on the test, if you wind up with extra time, you don't have to check the solutions, but you certainly could. Questions on the idea of like bases? Okay. What if you're not able to use like bases? What do you do instead? So here for number 2, the first thing I'm going to do is add 3. So 5 to the 2x equals a positive 12. I would hopefully think that you would understand that there is no common base to a 5 and a 12. So in order to solve this problem, you're going to have to log both sides. How do you know what base to log both sides? Whatever the base of the exponential is, that is the base that you're going to log both sides. So you are now going to log base 5, the left side. And because it's an equation, whatever you do to one side, you must do to the other. So log base 5, the right side. Earlier, I mentioned that if there was a no solution, it would come up organically. What I mean by that is instead of this being a 12, what if it were a -12? If that were a -12, you would not be able to do it, and you would say no solution. It would just happen on its own. You don't have to go back and check your answers. So it doesn't happen in this case, but again, if it did happen, if that log was a -12, then you would say no solution. So again, it just falls out by itself. You don't have to go looking for it. What now? Well, log base 5 of 5 to the something. I just showed you above that that cancels, and you're left with just the 2x. Again, if you want to know why that happens, go back up to the top of the page. That's the rule in yellow. If you have log base something of the same base, those just cancel, and you're left with the exponent. So 2x is equal to, how would I calculate this in my calculator? 3 words. How do I find log base 5 of 12? What property do I have to use? I don't know that I'm hearing it. 3 words. Cobb, change of base. Again, guys, I don't know if it's quiet out there because we're tired or because we don't understand, but if it's the latter, sounds like we have a lot of work to do before the test. So this would be equal to log 12 divided by log 5. And remember, when you're doing change of base, it's log for both. In order to get the x by itself, you would divide by 2. A better way of saying divided by 2 is multiplying by a half. So your answer x is equal to 1/2 log 12 divided by log 5. And now we have to calculate that. So again, you should have a calculator. You can do it in 1 step or 2 steps. It's up to you. Go ahead and do the log of 12, close the parentheses, divided by the log of 5, close the parentheses. Then either hit enter and then divide by 2, or multiply by a half in the same step, whatever works for you. Somebody go ahead and tell me what you get for your answer, rounded to 3 decimal places. 0.772. Rishi, is there a problem with that calculator? Are you sure? Because I just charged them all. All right, here. Borrow mine then. I did just charge them all, so I'll have to check that. Okay. And again, you should know how to find both of these for me. One of them is what we call the exact value with the logs, and the other is the decimal equivalent. It depends on how I ask you for the answer. Like if it was a multiple choice, I could give you either. On the test, I could say, give me a decimal, or I could say, give me the exact value. So the exact value would be the first one. The decimal would be the second one. Let's keep all that in mind as we now do the next 4 problems. Again, if you're going to find me the decimal, you must round to 3 decimal places. I don't really think we need to do very many more that involve like bases because we did a ton of those in the beginning of the chapter. So we're going to focus more on the log ones. So consider, if you would, number 3. Tell me algebraically what is the first thing that I should do. divide by 3. So if you divide both sides by 3, you get e to the 2x plus 1 equals 4. Seems obvious that e and 4 cannot be like bases. So you are going to have to take the log of both sides. Because of the fact that this is an e problem, you are going to take the natural log of both sides. So you're going to ln the left side. And again, because it's an equation, whatever you do to the left, you must also do to the right. Tell me what happens to ln base e of e to the something. What is that whole left-hand side simplify to be? 2x plus 1. Again, that's the property from above. So 2x plus 1 equals the ln of 4. Exact value-wise, you would take the ln of 4, you would subtract 1, and you would divide by 2. Again, that is what I call the exact value. I put a parentheses around the 4 just so you understand that you have to take that ln and then subtract 1. And then go ahead and make sure you can find me the decimal equivalent. So again, I would recommend doing the ln of 4. Make sure you close the parentheses, minus 1. Then I would hit enter. And then in the second step, I would divide by 2. Go ahead and do that. Somebody tell me what you get. Somebody besides Max, because he's given me all the answers, and I want to make sure that we can spread it around. So who else is going to help me out? 0.193. Okay, good. Questions? And again, while you do not have to check that answer, certainly if you wanted to, you should get an answer of 12 or slightly rounded to 12, because if you round your answer, then you won't get exactly 12, which is fine. How about another one, number 4? Tell me algebraically, what's the first thing I should do? Subtract the 4. And then don't be fooled. You might think that 2 and 6 share a common base, but they actually don't. 2 squared is 4, 2 cubed is 8, 6 is not really a like base. Whatever the base of the exponent is, in this case 2, you are going to log base 2 both sides. On the left side, log base 2 of 2 to the something cancels out to be 3 minus x. On the right side, log base 2 of 6. In order to find the answer, the easiest way is to move the x to the right and subtract the log to the left. So 3 minus log 6 divided by log 2 is equal to x. And again, just as a reminder, I moved the x to the right and I subtracted this to the left. I wrote this as follows because it's change of base. And now go ahead and see if you can calculate it. So again, you might want to do log 6 divided by log 2, hit enter. And then if you do 3 minus, you can just pull up the answer. If you do second, I don't have my calculator. Oh yeah, so you can do that too, but hold on, I can just pull mine up right here. Using the answer feature is something that if you don't know, it's actually quite handy. So let me just show it to you in case you don't know it. I'm leaning more towards this test being calculator versus no calculator, but I'll let you know for sure. So if I wanted to calculate this, I might start by doing log 6, close the parentheses, divided by log 3, close the parentheses, and get an answer. If I don't want to have to type that whole thing in, I'm going to do 3 minus, and then if you do second, the negative sign, that answer means the previous answer, and that will just do it for you without having to type anything in. Oh, no, hold on. Sorry, it was log 2. Figures. So log 6 divided by log 2, hit enter, and then 3 minus second negative will give you your answer. And again, if you don't need to do that, I don't care how you plug it in your calculator as long as you get the right answer. So if you have a different way, a better way, I am all for it as long as you do in fact get the same answer. Let me just put that here on the side so that we have it. And again, I'm going to write that as 0.415. Make sure that depending on what I do ask you for on the test, you could find me both, whether it's the exact value or whether it's the decimal. Questions on either of those two? Okay, let's finish up this section and then we'll take a little break. Again, these are your exponential equations, which means you can either solve it with like bases or you can solve it using logs. Here for number 5, there are more than one e, and there are some terms that don't have e's. Look carefully at this problem. It kind of looks like what? Yeah, I know there's e's, so it's clearly exponential, but it kind of looks like a quadratic. So what do we normally do with quadratics? We factor them, and it turns out we're going to do the same thing here. If you have an even exponent to start, and then half that exponent in the middle, and then no exponents at the end, that's how you know that you can factor it like a quadratic. This is what we call quadratic form. So normally you do 2 parentheses, and normally you do x and x. In this case, you're going to do e to the x and e to the x, because if you were to multiply those, you would get e to the x plus x, which is e to the 2x. Then you're still looking for 2 numbers that multiply to be -5 and add up to be -4, such as -5 and +1. You are then going to take each of these quantities and set them equal to 0. So either e to the x equals 5 or e to the x equals -1. In order to get rid of the exponent, you're going to ln both sides. So ln of e to the x equals the ln of 5. ln of e to the x equals the ln of -1. Well, okay, so first let's just go in order. What happens to ln of e to the x? It just becomes x. So ln of 5 is what we call the exact value, and it has a decimal equivalent, of 1.609. And then I hear quite a few of you saying that the one on the right is not going to work. You are correct, but why does it not work? You can't take the ln of a negative. I mean, try if you want to, but your calculator will tell you no. So this is what I meant earlier when I said if there is not an answer, it will just happen organically. You don't have to actually check it. So there is just one answer to this problem, and it is the ln of 5, or 1.609. Questions? Okay. Finally, as hard as it could possibly get, which is why I put those stars there, okay? If I were going to have you do this on a test, I would certainly not ever have you do it more than once. Take a look at this problem. Can anybody tell me why this problem is going to be so much harder than the rest? Both sides have exponents. So the fact that both sides have exponents means it's much harder than the first 2 in this section, and it looks nothing like a quadratic, which means I can't do it like number 5. So taking a look at both sides, I'm going to have to use a log. Like base isn't going to work here. Well, how do I know if I should do log base 2 or log base 5? I don't. So I just cut those out altogether, and I use an ln instead. ln is the great equalizer. You can do it for anything. So I'm going to ln the left side, and I'm going to ln the right side. And again, just to say it a second time, the reason why I'm lnning, how do I know if it would be log base 2 or log base 5? I don't know, so I'm just going to use an ln instead. Unfortunately, because it's an ln, this does not simplify. I can't do it unless it was base e. So while I can't simplify, what I can do is use a different property of logs, which say I can take these exponents and I can move them down to the front. So x plus 2 times the ln of 2 equals x minus 3 times the ln of 5. Then I'm going to distribute on each side x ln 2 plus 2 ln 2. Distribute on the right side x ln 5 minus 3 ln 5. Kind of looking like a bit of a mess here. There are 4 terms. I would say 2 of them have something in common and 2 of them don't. Any idea what I mean by that? 2 have x and 2 do not. So I'm going to put all the x people on the left and all the non-x people on the right. So over on the left, x ln 2 minus x ln 5 is equal to negative 3 ln 5 minus 2 ln 2. So all the x people on the left, all the non-x people on the right. If both of these guys have an x, but I would prefer for the x to be by itself, what could I do to the x? Factor it out. And then tell me what would be the last thing that I need to do in order to get this x all by itself? Divide. So negative 3 ln 5 minus 2 ln 2, all divided by ln 2 minus ln 5. Again, it looks a little gross. If I were going to ask you to do this on the homework or on the test, I would never ask you to do it more than once, because if you can't do it once, you certainly can't do it more than once. And believe it or not, that is actually fairly easy to type into the calculator. But just to save you a step, it would be 6.782. Yes, Max?
So I thought earlier you said you use the base of whichever number is lower. Did you say lower or
whichever one has the exponent. Yeah. Okay? Yes, you could do log base 10, but again, ln base e, LNs are a little bit easier because you don't have to use the change of base formula. So that's what I would recommend. But yes, it would also work with log base 10. So we're going to take a little break, but to get into the break, everybody try the last problem. That is using the rules from the front. You have to do a little bit of rewriting, but go ahead and see if you can simplify 7. Whatever you get for your answer, leave it and then take a little break, and then we'll go over it in about 10 minutes. Okay, so again, go ahead and try that problem. See if you can just simplify it. I'll give you a clue. It simplifies to be something with an x. See if you can simplify it, and then let's take like a 10-minute break. Okay, so you work on that. I'm going to pause my video here. Alrighty, so I had asked you to try number 7 to see what you could come up with. Hopefully the first thing that you did was realize that 64 needed to be a base 4 or the property would not work. So I went ahead and rewrote that as 4 to the 3rd, which becomes 4 to the 3x. Once you do that, you're now going to use the property twice. Once log base 4 of 4, that cancels. So keep the 5, bring down the 3x, and you're going to multiply those. So that's going to give you a 15x. Then e to the ln base e, those simply cancel to be x. So this is plus x, which means 15x plus x should give you an answer of just 16x. Not e to the 16x, not anything to the 16x, but literally just the number 16x. And again, do not change my problem. Do not set it equal to anything to solve. You're just going to leave it as such. So questions on that one? Okay, so on the front side, we were solving exponential equations, either using like bases or turning it into an exponential. There are also 2 ways to solve logs. And for the 2 ways to solve logs, you're either going to use like logs or you're going to exponentiate. You must, for these, check your solutions. Remember, the domain of a log is 0 to infinity. That means you cannot have the log of 0, nor can you have the log of a negative. So anything that creates either of those has to be disregarded. So first, let's do number 1. We're going to solve that with like logs. So again, to do like logs, you have to have a single log on the left, followed by a single log on the right. We don't currently have that, but at least everybody is base E. That's good. Tell me what I should do with these logs that are being added. I should change it into what? Multiplication. And not only is it multiplication, but you have to make sure that you distribute. So ln of x squared plus 2x equals ln of 8. The reason why this is called the like log strategy is because both sides have logs. So you can ditch the logs and simply set the insides equal, the arguments. This is now a quadratic. We like our quadratics best when they are equal to what? 0. So go ahead and subtract the 8. If I'm feeling nice, it will factor. If not, you might have to do the quadratic formula. What are factors of negative 8 that add up to be positive 2? Plus 4 and negative 2. That means that x could be equal to -4 or could be equal to 2. How do you know for sure? Well, go back to the original problem. Remember, always the original. And then locate all of the x's, so they're in purple. And then you have to check. Everywhere there's an x, if you plug in a 2, you get the ln of 4 and the ln of 2. No zeros, no negatives means that 2 is a winner. When you plug -4 in, unfortunately, it does not work in either one, so you go ahead and cross that out. Remember, if you have 2 possibilities, they could both work, neither could work, or only one could work. It's perfectly fine in all instances. Questions? Hopefully, by looking at number 2, clearly you can see that it is not a like log situation because of the fact that there is only logs on one side. So if there's only logs on one side, at some point you're going to have to turn it into an exponential. The first step, while you could take that 5 and move it up to be an exponent, that would give you something to the 5th power. That's a terrible idea, so just go ahead and divide it away instead. Then, because it's not a like log, and because you cannot do any other logs, you have to exponentiate both sides. So again, we are now going to exponentiate both sides. That just means turn it into an exponential. One way to do that is with the loop. The other way to do that is whatever the base of the log is, you're going to take 4 to the left equals 4 to the right. That's what we mean to exponentiate both sides. You're making both of the sides an exponent of 4. Why 4? Because it's log base 4. Why do I do that? Well, if you have 4 raised to the log base 4, what happens? It cancels to be x minus 6. What is 4 to the third? 64, which means your answer is potentially 70. In order to know for sure that it works, everywhere there's an x, put a 70. 70 minus 6 is 64. I don't even have to finish checking it as long as it is not a 0 and not a negative. So again, your 2 options for solving log problems are either like logs or exponentiate both sides. Question? Okay. Last couple here, make sure that you do the appropriate method at the appropriate time, and if needed, round to 3 decimal places. So consider, if you would, number 3, logs on 2 sides but not on the other. Tell me, how can I combine these logs on the left if there is a subtraction? Divide them. So this is log base 2 of the top divided by the bottom. Again, because there is only a log on both sides, I know that to solve, I am going to have to exponentiate both sides. Whatever this base is, I'm going to do 2 to that and then 2 to the right. That's what it means to exponentiate. The reason why I do that is because 2 to the log base 2, that just becomes x plus 2 over x minus 1. What's 2 to the third? And I'm going to put that over 1 as well. I do that so that I can easily cross multiply. And of course, when you cross multiply, don't forget to distribute. 8x minus 8 equals x plus 2. That potentially means that 7x equals 10, which means that x could be equal to 10/7. In order to know for sure, everywhere there's an x, put a 10/7. 10/7 plus 2, I don't even care what it is, but it's positive. 10/7 minus 1 is 10/7 minus 7/7. That's a positive number, so I'm good to go. Again, all you have to do is check that you don't get 0 and you don't get a negative. Compare that, if you would, to number 4. In number 4, it's logs as far as the eye can see. So if it's logs as far as the eye can see, it's a like log problem. Start by taking this addition and turning it into what? Multiplication. So this becomes the log of distribute x squared plus 3x equals the log of 10. Log on each side means ditch the logs and set the arguments equal. When you set the arguments equal, that is a quadratic. Of course, we prefer our quadratics equal to 0. Are there factors of -10 that add up to be +3? And if so, what are they? +5, -2, which means my answers could be -5 or could be 2 or could be both or could be neither. How do I know for sure? Well, everywhere there's an orange, I have to test them. If I plug in 2, I get 5 and 2. That's good. If I plug in -5, I get negatives for both. Not good. Again, don't be afraid to check those negatives because they do work a handful of the times. Why don't you go ahead and very quickly do the last two? So everybody try number 5 and number 6. I am going to do them up here while you do them at your seats. We will go over them in just a couple of minutes. So last two problems of the lesson, see if you can do 5 and 6. Make sure you check your answers if needed. And we'll go over them shortly. The answer for number 5 is in fact -1. There's nothing to do right from the jump. You realize they're both ln, so you can immediately set the arguments equal, and you get a potential answer of -1. If in the original you plug a -1 back in, you just get the ln of 2. The ln of +2 is perfectly legal, which means the negative answer does in fact work. Again, I did that purposefully because I don't want you to just automatically throw the negatives away. Please make sure you check in the original. Finally, number 6, start by adding 3 to both sides. Then realize that you're going to have to exponentiate because it's an ln. You're going to e both sides. On the left, cancels to be 2x minus 1. On the right is e squared. Your exact value would then add the 1 and divide by 2. And if you plug that into your calculator, it is 4.195. Any questions? Okay, hold on. Let me just go ahead and stop